Hello everyone. In this video, it's a continuing video about 2.4. I'm going to talk about at infinity limits or limits at infinity is something else. As I told you, x approach to infinity or minus infinity. This means the limit at infinity, but infinite limits means that you have a limit is going to number, but here you get the result will be zero, infinity or minus infinity. For example, we have x approach to 1 over x approach to 1 over x, but x approach to 0 from right side or from left side You know, in both case, here we have 1 over x. When I'm going to the positive infinity, the x will go to what? To infinity. When I am going to the 0 to the negative part, the y will go to what? To minus negative infinity. So this is the infinite limits. Okay, that's all about this one. And do not forget about that. So if I go to the any number, and I get the infinity or negative infinity, means that we have a vertical asymptote at this number. For example, here at 0 I have a vertical asymptote. Why? Because here I'm going to the infinite and negative to 0 and negative 0, but the result is are what? Infinity and minus infinity. So first of all, try to solve this one. For example, we have x approach to what? X approach to 1 here, or x approach to 1 to here, from the right and left side. And you know, as usual, you get infinity and minus infinity. So in that case, 1 will be our asymptote. 1, look here, 1 will be our asymptote. Why? Because in the positive here I got positive infinity, and when I'm going to the 1 from left side, I got what? I got negative infinity. Okay, dear, that's all that we have. How about the x square? 1 over x square, limit of 1 over x square. You know, in both case, if is going to 0 from positive part or from negative part, you know, by the graph or by anything else you can imagine, we are going to 0 here, and the result will be infinity and infinity, because both sides is going to the curve like that. Okay, dear, that's all I have. So this is about getting the infinity and negative infinity. This example is one of the most important examples. Why? Because it lets you to know how to solve the exercise and how to imagine the value here. Okay, dear? So please concentrate with me, and that's all. Now, for the first part, if I put 2, I will get 0 over 0. Okay? But here, we are not putting the value directly. So, why? Because I know x minus 2 square over x square minus 4, x approach to 2. Because there's an algebraic step. We can do x minus 2 or plus 2 or x minus 2 and x minus 2 square. So limit, because we can remove this exponent with that one. So I get what? I get the limit approach to 2 x minus 2 over x plus 2. Now directly we can put it here, because 2 minus 2, 2 plus 2 is equal to 0 over 4 is equal to 0. So okay, 0, 0, 0. 0 is the number. Okay. So for the example, that's after this, we have another important example. Example B. The same things happen, but now I will get what? I will get, well, let me write down for you, x minus 2, x square minus 4, x approach to 2. Here, I cannot decide, because I will get what? I will get limit x approach to 2 for what? For x minus 2, x minus 2, x plus 2, and it remains x approach to 2 to what? to 1 over x plus 2. If I put 2 here, I get anything, any problem? No. So it's equal to what? 1, like a 1 over 2, and I get 1 over 4. Okay, so that's for part B. How about C? We have C and D and E, they are related to each other. C and D, they are the one package. Maybe in the exam, just I am going to give you E. Okay, so in the exam, I'll give you E. Let me write, let us solve this part, then later I am going to solve the other part. Okay, now I'm going to what? To do whatever you want to do. X approach to 2 from positive part. I have x minus 3, x minus 2, x minus plus 2. So what else? Is there any cancellation? No, of course. So why we made this one? Because we have x squared. X squared does not tell us anything. That's why we separated, we factored. Okay. So now I'm going to distinguish, you know, the denominator lower is greater than upper. So in that case, I will get what? I'll get 0, right? Right? No. Why no? Because this rule is not true for number. It's true for what? For infinity and minus infinity. What I want to say that do not try to solve it by the upper and lower, because here's the number, here's no infinity and that's infinity. So this is a caution. Not careful, okay? So thus we cannot decide is equal to what? Bash. What else? Now it's the number. I am going to put the number. If I put the number, for example, greater than 2, for example, 2.01. So I am going to account in your mind, this x is like that. So 0.2 minus something here, I will get negative part, right? Good. How about if I put 2 here, plus 2, 2 plus, let me see, 2 plus. If I put 2.00 here, I will get what? I will get positive. Why? Because 2.00 minus 2 is equal to 0.00, so that's why I say positive. How about here also I will get positive. So the result will equal to what? Negative, positive is equal to negative. Okay, so just I recognize the sign. So for what? Because I know if I put 2 here, I will get 0, right? If I put 2 here, I will get 0. So 1 over 0 is equal to infinite. But which infinite? Positive infinite or negative infinite? You don't know. So that's why we should substitute this value here. And imagining that this value is equal to what? Equal to negative infinite or positive infinite. So that's why we say is equal to negative infinite. Now I'm going to solve D, which is the same example, the same number, but just the change is from here. Okay, so you can directly say is equal x approach to 2 negative x minus 3 over x minus 2 x plus 2. Okay, now it's time to what? I know is equal to infinite, but which infinite? Positive or negative? I don't know. We should test by 2. So 2, I'm going to imagine in my mind is equal to 199. Why? Because 2 from left side means that something like that, 199. So if I put 199, I will get what? Here, in the numerator. I'll get negative, right? 199 minus 3 is equal to negative. How about here? 199 minus 2, also I'll get negative. How about here? I'll get positive. So positive, negative, negative, negative over negative, positive. That's all I want to say. So in that case, because in the E, because in C and D, I got positive infinite and negative infinite and positive infinite, so the limit does not exist. Even both of them are equal, are positive infinite. Infinite does not exist because limit is going to what? The limit is going to infinite. That's all about example E, C, D, E. Okay, dear? That's why it does not exist. Now, how about this? I think it's easy, right? It's easy. Why? Because I have a 2 power cube denominator, and you can account again. So we solve for you. It's okay. we have a limit x approach to 2, 2 minus x, x minus 2 cube. You know, if you change this one, you get the same, right? That's why he changed it. So there's negative x minus 2, x minus 2 to power 3. Now it's time to x approach to 2. This will reduce it to 2, and this one will gone. So it remains x approach to 2 minus 1 over x minus 2 square. Here is not change. Why? Why nothing will change? We cannot. Why we are not doing anything? Because I have a here usually is positive. Denominator here usually positive. Why? Because I have a square. So if I put 2 minus 2, 1, 0, anything, I will just get positive things here. And how about numerator? Also always have a negative. So that's why it remains negative. Now, how about the value? If I put 2, this is about the sign. How about the value? If I put 2 here, I'll get 0. 1 over 0 is equal to infinite. So that's why we say is equal to minus infinite. Okay, dear? That's all about the graph and how to deal with the value and substitution with the value of, what do you say? Now, give me 1 second. It's the last page. Let me see here what we have. In the last page, as we mentioned, I mentioned before, vertical asymptote is any number that we put to the graph and I get what infinite and minus infinite. For example, before, this is the I'm going to talk about x approach to what? For example, approach to you see in this example, find horizontal and vertical asymptote. So you know about the horizontal. We say we will take x approach to infinite or minus infinite. Any number will be our horizontal. Now this is the function. Your function is x plus 3, x plus 2. Now I'm going to take what? To take x, okay, to infinity or minus infinite. It does not matter. Let be x to be infinite. X let be to approach to infinite. So I get what? Because they are equal. Now time for saying about thinking about the three cases. Why? Because I have polynomial over polynomial. So the exponent are equal, so is equal to 1. So 1 will be what? Our horizontal asymptote. Okay. How about vertical asymptote? We don't forget about the 1 is horizontal asymptote. 1. How about vertical asymptote? We say we will take something. This is our function. That will give us infinite or minus infinite. So x approach to something. This box to this box. This box will be our asymptote. So which number I should put it here for getting the denominator to be 0? Surely minus 2. Am I right? Minus 2. So that's why I say minus 2 also. Here's a 1, 2, minus 2 will be our vertical asymptote. And here we have negative infinity and negative positive infinity. That's why. What else? We can find the value with a minus 2. You can see minus 2 and 1 is our vertical asymptote and horizontal asymptote. Okay, dear, that's all that you say you want to know about the vertical asymptote and other part. Now you have another example on the page 8. You have this denominator and you know it's equal to 8 over x minus 2 x plus 2. So you have 2 asymptote, because if I'm going to 2, I will get vertical asymptote. If I'm going to -2, also I will get another vertical asymptote. And we mentioned before about the sine, cosine, anything that these are our asymptote. In the tan, you have pi over 2. In the secant, also you have a pi over 2. How about cosecant and cotan of x? You know about the asymptotes. It's about the other picture. Now, and forget about the space. Really, we don't mention the space. It's okay. It's not included to this semester. That's all about 2.4. I hope you are studying well, and because later we are going to talk about the continuity with last things in chapter 2. So please try to study well, and that's all. Thank you.